Hi everyone, welcome to Brilliant Classes. Here we are going to discuss the last year JEE main chemistry questions in detail. Let's start with question number 1. Here we have the relative strength of interionic or intermolecular forces in decreasing order is, right? Here the forces is between, one is given ion dipole interaction, one another is dipole interaction, and the other one is between two ion. These are the interactions. We studied in States of Matter chapter, grade 11, there are different type of intermolecular attraction, right? We know if the charge density on the species when increases, what's the point? If the charge density on a species increases, then the force of attraction also increases. See, while you coming to an ion, if you consider a sodium ion, it's fully positively charged one, right? Na plus. If you consider a Cl minus, it's completely negatively charged one. A fully charged species is an ion, and another one fully charged species, one another ion. Their interaction that will be greater in magnitude because their charge density is very higher. While you coming to a dipole, what is a dipole? You know very well. Dipoles, they are charge separated, right? They having partial charges. If they having partial charges, their magnitude of attraction also decreases. So we can say that between two ion, they are fully charged, their interaction will be very greater. An ion and one dipole, there will be little lesser than ion and ion. And while you're coming to dipole and dipole, it is very weak force of attraction. So we can say that ion-ion interaction will be greater in magnitude first, and then ion-dipole interaction, and the very least one is dipole-dipole interaction. So the answer, we can write it as ion-ion, ion-dipole, dipole-dipole. Answer is option C. Right. Let's go to question number 2. The oxidation number of potassium in K2O, K2O2 and KO2 respectively is. Mostly they will ask you the question, what is the oxidation state of oxygen in these kind of species? But here there is a simple question, what is the oxidation state of potassium in these kind of species, right? Very simple. The species are given K2O and another one is K2O2 and the last one is KO2. You know that in K2O, potassium is an alkali metal. Alkali metal, what is the common oxidation state? That is +1, right? So here in all these cases, potassium is in +1 oxidation state because it is an alkali metal, +1 oxidation state. What about oxygen? This oxygen, while you were discussing, this 2 actually is contributed from, right? This oxygen, it's actually O2 minus, and this here, this 2 is contributed from oxygen, that is O2 2 minus, and here that is 1, right? This 1 is contributed from O2 minus 1. What are these species? When an oxygen existing in -2 oxidation state, it is called it as oxide, right? Oxide. Here you can see 2 oxygen atom that is in 2- state. So what will be the oxidation state of 1 oxygen? It will be -1 oxidation state, right? And here, what is mean by -1 oxidation state? That is said to be what? Peroxide, right? Peroxide. While you coming to O2 minus, here 2 oxygen with a -1 charge. So 1 oxygen will be -1/2. The oxygen in -1/2 oxidation state is known as superoxide, right? It is said to be superoxide. Superoxide. Right. So in all these 3 cases, potassium is in +1 oxidation state, but the oxygen in first case it is in -2, that means oxide. Second case -1, therefore peroxide. In third case -1/2 superoxide. So here the question, potassium in all these cases, the answer is +1 oxidation state, right? Okay, let's go to question number 3. Here we have, at 35 degrees Celsius, the vapor pressure of carbon disulfide is given. Okay, let's write. The vapor pressure of CS2 is given as 512 millimeter of mercury. And the second one is given acetone. The pressure of acetone. The pressure of acetone is given 344 millimeter of mercury. A solution of CS2 in acetone, total vapor pressure of 600 mmHg. So here it is given P total, right? Total vapor pressure of the mixture is given that around 600 millimeter of mercury. Okay, fine. The false statement, while reading the question, student, very careful, the false statement regarding this. You know, in the chapter solution, your grade 12 solution, your second chapter, you may study there are two types of solution. That is ideal solution and non-ideal solution. What is an ideal solution? The solution which can obey Raoult's law for a wide range of concentration and temperature. Then what about a non-ideal solution which will not obey Raoult's law? And non-ideal solution we again classify into two. They are positive deviation and negative deviation, right? We have studied lot of example for positive deviation and negative deviation. What are the example for positive deviation that we studied? See, ethanol with acetone, right? Ethanol with acetone, methanol with water, ethanol with water, carbon tetrachloride with benzene, cyclohexane with cyclohexanone, and this one. Which one? CS2 with acetone. So CS2 with acetone belongs to a positive deviation non-ideal solution. What are the examples you studied for negative deviation? Like chloroform with acetone, chloroform with benzene, chloroform with diethyl ether, water with nitric acid, sulfuric acid, hydrochloric acid, phenol with aniline. Lot of examples that we studied. So here with the question, acetone and CS2 belongs to the category positive deviation. So what are the speciality of positive deviation? We have studied lot of characteristics of positive deviation one by one. We know they will not obey Raoult's law, right? So here we can say PA is greater than P naught A into A, right? Means mole fraction. And one another case, PB is greater than P naught B into chi B. That is a mole fraction of the second component. So P total also will be very greater, right? Okay, fine. And second one, the another property we studied, the enthalpy of mixing is a positive value, right? It will be greater. And the third one, delta V mixing also will be positive value because it is positive deviation, student. While mixing, the volume change also will be very positive. And then we studied one of the important point, AB interaction is weaker than AA and BB interaction. What is mean by AB interaction? Between the two components, their interaction will be weaker than their individual component. For example, acetone and CS2, their interaction will be weaker than acetone and CS2 and CS2. That's the point for positive deviation. Now let's go with which is the false statement here. Option A. CS2 and acetone are less attracted to each other than to themselves, right? This point, their interaction will be weaker than their themselves. So this one is a correct statement. Question which is false. Option B, heat must be absorbed in order to produce the solution at 35 degrees Celsius. Heat must be absorbed. See, heat absorbing process is called endothermic reaction, right? Endothermic. When it becomes endothermic, you know, delta H value positive. Yes, for a positive deviation, delta H is positive, right? So delta H positive means enthalpy change positive mean it is an endothermic reaction. Yes, that is also correct statement. Coming to option C, Raoult's law is not obeyed by the system. Yes, it's a non-ideal solution. It's also a correct statement. So, mostly your answer will be option D. Let us check it. The mixture of 100 ml CS2 and 100 ml acetone has a volume less than 200 ml. No, it should be greater than 200 ml. That we studied. During this mixing, their volume mixing should be greater. It should be positive, right? It should be greater. So when you mix 100 ml acetone with 100 ml CS2, their volume, right? Their volume, total 100 plus 100, 200, but their volume mixing should be greater than 200. So delta V mixing should be greater than 200 ml. Greater than 200 ml. So that is a wrong statement here. It should not be less than, it should be greater than. So this is your answer. Option D. Question number 3. Answer is option D. Okay, let's go to question number 4. Here we have the atomic radius of silver is closest to. Simple one. Atomic radius of silver. Student, you should know the position of each and every element in the periodic table. It's compulsory, okay? So let's discuss with nickel, copper, silver, mercury, all are belongs to which one? D block, right? Okay, let's write. The first transition series, let me write it. What are there? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and we have copper and zinc. This is your first transition series, right? Or it is called 3D series. Now coming to the next one. Here already you mentioned the elements. Which of them? Nickel is there, okay. Copper is there, okay. And you have silver and gold. Where they located silver and gold? Silver and gold just below copper. Copper, silver, and we have gold. So copper, silver and gold, they are located in the same group. Okay. So here, nickel, copper, silver and gold, while you consider, the atomic radius of silver is closest to. Student, this first series is known as the first transition series, or it is called 3D series. The second one is called second transition series or the 4D series. And here it is the third transition series, that is your 5D series. You may study in your D and F block element chapter, that is about lanthanide contraction, right? Lanthanide and actinide contraction. What is meant by lanthanide contraction? It is a steady but slow decrease in size through a lanthanoid series, right? That is called steady but slow decrease in size is called lanthanide contraction. You have studied lot of consequences of lanthanide contraction. Like their separation is difficult, their basic character, covalent character, and one of the point is that due to lanthanide contraction, the second and third transition series showing similarity in property, right? Especially their atomic radius, everything. What is the point? Due to lanthanide contraction, second and third transition series showing similarity in their property, especially atomic radius. See, silver, the question, silver, its atomic radius matches with which of the following element? Silver, it's in second transition series, and the gold, it is in third transition series, right? So their properties will be almost similar. So gold and silver, their atomic radius are almost same. So your answer is option C. The reason is lanthanide contraction. Okay, fine. Let's go to question number 5. The dipole moments. Student, dipole moment that we studied in chemical bonding and molecular structure chapter, that is from your grade 11, right? Yes. So the dipole moment of the species carbon tetrachloride, CHCl3 chloroform and methane are in the order. Very simple. Carbon tetrachloride, their structure is what? Tetrahedral in geometry, right? They're having tetrahedral geometry. Okay, fine. What about CHCl3? That's also tetrahedral in geometry. Okay, fine. Let's go with the CH4. That is also tetrahedral in geometry. Fine. Now let's find out its dipole moment, all of you. Listen. Carbon and chlorine, while you consider, chlorine is more electronegative, right? So what happened? These electrons have a tendency to shift towards chlorine. Here we can draw the dipole moment like this. Then what about CHCl3? You know, carbon and hydrogen, while you consider carbon is more electronegative. Carbon, chlorine, while you consider chlorine is more electronegative. So we can show the representation of electron like this. And what about CHCl3? CH4, right? In this case, it will pull electron towards carbon because carbon is more electronegative. What is the point in CCl4? In CCl4, all the chlorines, what happened? You know, studied that in tetrahedral geometry, if all the species, if the all surrounding elements to the central atom, if they are same, their dipole moment will cancel each other. Their dipole moment will cancel each other. So all their dipole moments are cancel each other. So dipole moment is equal to 0. What about CH4? Here you see all these surrounding 4 elements are same in a tetrahedral geometry. So its dipole moment also will be 0. What about CHCl3? In CHCl3, this dipole moment, where is the resultant? Downward, right? If there is a resultant, we can say that it having a dipole moment, therefore it is polar. So it having a dipole moment. So what should be the order? CHCl3 having greater value, right? CHCl3 having greater value, and then CCl4 and CH4 having nu equal to 0. So we can write CH4 equal to CCl4. So what can be your answer? CHCl3 greater, CCl4 and CH4 0 dipole moment, they are equal. So your answer is option C. Right. Now let's go to question number 6. In comparison to the zeolite process for the removal of permanent hardness, the synthetic resin method is that we studied in grade 11, the chapter hydrogen. There are two types of hardness of water, right? Temporary hardness and permanent hardness. Temporary hardness is removed by mainly two methods. What are the two methods? One is by boiling. Second one by Clark's method, right? And permanent hardness is removed by mainly 4 methods that we studied. First one, treating with the washing soda, Na2CO3. Second one we studied, that is Kalgan's method. What is Kalgan? Sodium hexametaphosphate, Na6P6O18 is called Kalgan. And third one we studied zeolite method or permutite. It is also known as permutite method, or it is known as ion exchange method. What are that? Zeolite method is also known as permutite method, or it is also known as ion exchange method. And last fourth method that we studied, synthetic resin method. So let's compare zeolite and synthetic resin method detail. Here, zeolite. I told you zeolite is also known as permutite method or ion exchange method. What is actually zeolite? Zeolite is chemically sodium aluminium silicate. That's a compound NaAlSiO4. Sodium aluminium silicate is known as zeolite. Let's, what is meant by permanent hardness? Those hard water which contain calcium and magnesium ion, right? So let's treat this. NaAlSiO4, sodium aluminium silicate, when it is treated, means zeolite, when you treated with calcium ion. From where you are getting this calcium ion? From hard water. When it is reacted, you will get, calcium 2 plus, here you have the ion, Na plus and AlSiO4 minus. So you will get CaAlSiO4 twice plus Na plus. And here the Ca2 plus ion which displays this Na plus ion, right? So cation is exchanged. While you coming to the synthetic resin method, because we are comparing zeolite method and synthetic resin method. While you coming to synthetic resin method, student, there are two type of resin. They are cation exchange resin. cation exchange resin and anion exchange resin. Cation and anion exchange resin. Okay, let's study detail about that. Cation exchange resin, they are saying that it contains a cationic part, especially acidic part. Okay, means it contains H plus ion. But a anion exchange resin contains a basic part like OH minus. Let me give you one example for a cation exchange resin. For example, RH. See, RH, the species contain H plus, right? So it is a cation exchange resin. For example, anion exchange resin, let me take RNH3 plus OH minus. See, it contains OH minus ion. Let me treat with something. What? Calcium chloride. It is a permanent hard water because permanent hard water is because of calcium, magnesium present as they are either chlorides or sulfate. So calcium chloride contain the ion Ca2 plus and 2Cl minus, right? So let me treat the cation exchange resin with this cationic part, means Ca2 plus. Let me treat with this anion exchange resin with a Cl minus part. Okay, fine. Here Ca2 plus ion, it will displace this H plus ion. So what you will get? R2Ca. Ca will combine with the R and you will get H plus ion. Okay, fine. In the second case, the anion exchange resin will react with the Cl minus, and what will happen? The Cl minus ion and OH minus ion are interchanging and you will get RNH3 plus Cl minus plus OH minus. See, this OH minus, H plus and OH minus together, what is your compound? That's nothing but pure water. Pure water. Here what is happening? What is the difference between zeolite method and synthetic resin method? In zeolite method, only the cation part is interchanging. But in synthetic resin method, that is cation is exchanging and the anionic part also exchanging. So which is the best method, zeolite or synthetic resin method? Absolutely it is synthetic resin method. So in comparison to the zeolite process for the removal of permanent hardness, the synthetic resin method is, what's your answer? More efficient as it can exchange both cation and anions. That is the advantage of synthetic resin method over zeolite method. Okay, right. So let's go to question number 7. Among the following statement, that which was not proposed by Dalton. In your grade 11, the chapter Some Basic Concepts of Chemistry, you have studied Dalton's atomic theory. Mostly they given 4 postulates, right? Those who are reading NCERT textbook thoroughly, they can easily understand the concept. Dalton's atomic theory, 4 postulates are given. Question here, which was not proposed by Dalton. Let's see first one. Option A, matter consists of indivisible atom. Right? Absolutely it is proposed by Dalton. It is a correct statement. When gases combine or reproduced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. You have studied at a constant temperature and pressure. When these gaseous molecules are combining, they do so in a simple manner. Like what? They combine in a simple whole number ratio by their volume. And it is proposed by, not by Dalton. This law is called Gay-Lussac's law. You know, Gay-Lussac's law is applicable to gaseous system. So this second one is given by Gay-Lussac's law, not by Dalton. So your answer is option B. Let us check it with option C and D also. Option C, chemical reactions involve the reorganization of atom. It's clearly given in NCERT textbook, that same sentence here. These are neither created nor destroyed in a chemical reaction. Absolutely it is given by Dalton's theory. What about option D? Some atoms have same properties including atomic mass, right student? a particular atom, while you are considering, they contain a particular atomic mass. And also Dalton stated that atoms of different elements having different atomic mass. So this is also one of the postulate given by Daltons. So the answer is option B, which was not proposed by Dalton, that is option B. Now let's discuss question number 8. The increasing order of pKb for the following compounds will be. So the basicity is the question. You know, basic character that we studied in chapter amines grade 12, right? Here the basicity you can express in two ways, either Kb values or pKb value, right? You know, as Kb value increases, what happens to the basicity? You know, basic character or basicity increases. So as Kb value increases, basic character also increasing. At the same time, pKb value increases, the basic character or the basicity decreases. What's the reason behind that? You know the relation between Kb and pKb. You know, pKb is equal to negative log Kb, right? pKb is equal to negative log Kb. So Kb value increases, pKb value decreases. And coming to the question, let me take 1, 3 first. Here the first and third compounds amines are aliphatic one, and the second one is a cyclic one. Let us take the first and 3, then we can enter into the cyclic one. So the first compound is given that NH2 CH double bond NH, right? This is the compound given here. And the third compound given as CH3 NHCH3. This is the one. Okay. Let us discuss the basic character of these two compounds first, 1 and 3. Okay. Here, when this amine become more basic in nature, you know, the basic character depends on its ability to donate the lone pair faster. If the species is ready to donate the lone pair of electron, then we can say that it is highly basic, Lewis basic in nature. And here, see this nitrogen. What is the hybridization of this nitrogen, student? You know, the hybridization is calculated by the total sum of sigma bond and lone pair. You know how many sigma bonds are present on this nitrogen? This nitrogen is single bonded with a hydrogen. So 1 sigma bond, double bonded. So 1 sigma, 1 pi. So total there are 2 sigma bond with that nitrogen and there is 1 lone pair. So total is equal to 3. If the total sum of that hybridization that is equal to 3 means, what is the hybridization? 3 means 1 s orbital and 2 p orbital. So therefore sp2 hybridization. So this nitrogen is in sp2 hybridization. What about this nitrogen? This nitrogen, total there are 3 sigma bond, right? 1 with the CH3, 1 with other CH3, 1 with the hydrogen. There are 3 sigma bond and 1 lone pair. Total sum is 4. So the hybridization is sp3 hybridization, right? sp3 hybridization. You know, in sp2 hybridization, how much S character is present? You know, that is around 33.3% S character is present. In sp3 hybridization, the S character is around 25%. Why we are measuring S character? You know, as S character increases, its electronegativity of the particular element also increases. If S character increases, electronegativity also increases. So which nitrogen having greatest electronegativity, student? This one, right? First species nitrogen having greatest S character compared with the third one. So its electronegativity increases. Electronegativity increases mean it can't donate the lone pair of electron faster. What is electronegativity? Ability to accept a pair of electron, right? And one more. So as per this case, which is the more basic one? This will be the more basic one because it is ready to donate the lone pair because its S character is lesser. And one more reason, this is a alkyl group. This is an alkyl group. You know, alkyl groups are electron donating group. You know, electron donating group will increase the basicity. Because this CH3, it can donate electron, so the nitrogen lone pair will be nitrogen which will be highly electron rich one. If they are highly electron rich one, they are ready to donate the lone pair, they are highly basic in nature. So when you consider first and third compound is more basic than the first one. Now let's come to the cyclic one. And the second structure, here we have nitrogen NH and then double bond N. This is the one given here, right? And this nitrogen which having a lone pair, this nitrogen contain lone pair. And what is the hybridization of this nitrogen atom? Let us find out. See, this nitrogen 3 sigma bond and 1 lone pair, therefore sp3, right? This is in sp3 hybridization. This nitrogen 1, 2, 3 sigma bond and 1 lone pair, that is also sp3. There are 2 sp3 hybridized nitrogen. What about this nitrogen? 1, 2, count only sigma bond. So 1, 2, 2 sigma bond and 1 lone pair, total 3. Means this nitrogen is in sp2 hybridization. So there are 2 sp3 hybridization. So what happened? Their s character is lesser. So they are lesser electronegative one. So they are ready to donate lone pair, right? So in first case you see that is sp2. In this third compound sp3. In second compound there are 2 sp3. So its basic character can be increased little bit more than the third one. And one more reason, all of you listen carefully here. This NH3, suppose it's donating, it's a base, right? So suppose it is donating the lone pair and getting one H plus. What will happen? If it is donating this lone pair and gaining one H plus, so you will get like this species, right? It is a base. And if it is this nitrogen positive, there is a chance to occur resonance. How is the resonance possible? This lone pair can be shifted here and this pi electron can be shifted here. So this N can be positive, this N positive will be cancelled. Same like here also. So this cyclic compound, it is resonance stabilized also due to the donation of the lone pair. So this cyclic compound is highly basic in nature. 2 reasons. It contains 2 sp3 hybridized nitrogen atom and the resonance stabilizes the compound by the donation of the lone pair. Therefore, the basic character we can write that the greater basic character, what we can say, the second compound, the cyclic compound is greater in basic nature. And while you're coming to the next one, third one, and then first one having very least basic. But the question, increasing order of pKb, you know, pKb value increases, basic character decreases. So just opposite will be the order, right? 2 less than 3 less than 1. See, 2 is the greater basic one. So its Kb value will be higher, pKb value will be lesser, right? So this will be the increasing order of pKb. So the question number 8, this will be the answer. Question number 9, what is the product of following reaction? Means hex 3-vinyl is first treating with NaBH4, then PBr3, then magnesium dry ether, carbon dioxide, then acid hydrolysis. Okay, fine. We have the compound hex 3-vinyl. Hex 3-vinyl, 1, 2, 3, 4, 5, 6. It's an aldehyde, right? CHO will be the compound. This is the hexanol. So this should be the greatest functional group, highest priority, number 1, number 2, number 3. In third position, there is an alkyne, hex 3-vinyl. This is the compound we have. Okay, first we are going to treat it with, NaBH4, sodium borohydride, NaBH4. You know, sodium borohydride is a reducing agent. It can reduce the aldehyde into primary alcohol, right? So we will get the compound, triple bond, nothing will happen. it becomes CH2OH, right? CH2OH. Aldehyde becomes primary alcohol. Second one, what is the second reaction? PBr3. You know, PBr3 is nothing but it's a brominating one. So bromine will given instead of OH. So it converted to, here it becomes CH2Br, right? CH2Br. After that, we are treating with magnesium in presence of dry ether. Magnesium in presence of dry ether. You know, magnesium dry ether, when we are treated with a alkyl halide, it is converted to Grignard reagent. You know very well. So the compound becomes CH2MgBr, right? CH2MgBr. After that, you are treating with carbon dioxide. See student, carbon dioxide, the mechanism you have studied in carboxylic acid part. What is carbon dioxide? Let me write it like this: C double bond O double bond O. You know, in CH2Mg, Mg plus and CH2 minus. So the nucleophile will attack on this carbon and this becomes O minus. This become O minus. So we can write this triple bond and here CH2. Where the CH2 attack on this carbon? What is present on this carbon? A double bond oxygen and here O minus. To this O minus, what will attack? The Mg plus Br, right? Mg plus Br will attack. After that, acid hydrolysis means you are treating with H3O plus. When a Grignard reagent, the part, when it is treated with a H3O plus, what will happen? To this one, H plus will attack. Here, OH will attack, OH minus. So what are you getting the product? Here, nothing happened to the triple bond, okay? Nothing happened to the triple bond. And here, CH2. And here you have C double bond O. And here you have OH. So this is your compound. So in this option, it is very easy to understand because only the compound which retain the triple bond is in option B, right? So the answer is option B. Now let's go to question number 10. Question number 10, the number of orbitals associated with quantum numbers. Very simple question. Structure of atom, right? Grade 11, second chapter, structure of atom. Number of orbitals associated. We have a direct equation actually to calculate the number of orbital, that is equal to n square. Here n value is given 5, so 5 square is equal to 25. So you got the answer, and spin quantum number is also given plus half. Let's see very detail about that. It is given that n is equal to 5. What is n? The principal quantum number is given 5. And it's given that spin quantum number is plus half. Okay student, here n is equal to 5 means we can calculate the azimuthal quantum number, right? What is azimuthal quantum number? L, that is 0 to n minus 1. You know, azimuthal quantum number is ranged from 0 to n minus 1. So the value will be 0 to 5 minus 1, that's equal to 4. So the values are 0, 1, 2, 3, 4. These are the values of azimuthal quantum number. You know, azimuthal quantum number gives the idea about which is subshell, right? Here, if it is your 0, the value of L, it will be s orbital, it will be p, d, f, g, etc. And what is the n value? 5. So it will be 5s orbital, 5p, 5d, 5f and 5g. You know how many orbitals? How many s orbital that you have? Only one s orbital, right? And how many p orbital we have? 3. px, py, pz. 3 plus. How many d orbital we have? 5. dxy, dyz, dxz, dx square minus y square and dz square. So it will be 5. How many f orbital you have? 7. And how many g orbital? 9. So total how many orbitals are present with n is equal to 5 student? That's equal to 25. And they given spin quantum number also. Suppose if they are asking you the question, the same question, and I'm just changing the number of electrons associated with these quantum numbers. The again answer will be 25. How it comes? You know, spin quantum number, it is given as plus half, right? You know, there are total 25 orbitals. 25 orbitals are there. You know, in one orbital, maximum 2 electrons can occupy, right? Maximum 2 electron will be there, with one with a plus half, one with a minus half spin. And here, total there are 25 orbital, mean there will be 50 electron, because one orbital, 2 electrons. So total there will be 50 electron. Among that 50 electron, half of them, means 25 electron will be with a plus half spin, and the other 25 will be minus half spin. So the number of electrons with n equal to 5 and ms, spin quantum number, equal to plus half, that also will be 25. So here the question, number of orbital, no doubt here, answer is 25, that is option C. Right? Now let's go to question number 11. The purest form of commercial ion. You studied in grade 12 the metallurgy chapter, in which how to extract iron commercially. You have studied a blast furnace. After all the process, you will get a molten state of iron at the down part of this blast furnace. That is called pig iron, right? That is the most impurest form of iron, right? Pig iron. Why it is called a impure form of iron? Because it contains 4% carbon as an impurity, right? It contains 4% carbon along with some other impurities like silicon, phosphorus, sulfur, like that. And while you coming to pig iron, so this is the most impurest form of iron, but the question is the purest form of commercial ion. The pig iron that you can convert it to another one, that is called cast iron, right? Cast iron, from pig iron you can make little more stable, or you can say that it is a purest, some more purest form of iron, that is called cast iron, and it contains around only 3% carbon as impurity. But this is not the purest form. The purest form of commercial ion is known as wrought iron, right? That is called wrought iron. It's prepared from cast iron. It's contained only 0.2 to 0.5% of carbon. So this is the most purest form of the commercial ion. That is nothing but wrought iron. So your answer is option D. Okay, let's go to question number 12. In question number 12, the theory that can completely or properly explain the nature of bonding. Student, it's a coordination compound. What is a coordination compound given here? NiCO4, right? Tetracarbonyl nickel with a 0 oxidation state is given. Okay. For this compound, its nature of bonding is explained by which of the theory? Actually, we studied 3 theories in coordination compound chapter: Werner's theory, valence bond theory, and crystal field theory. But actually, molecular orbital theory we studied in grade 11 chemical bonding chapter, right? Okay. You know, Werner's theory states that every central metal atom in a coordination complex contains 2 types of valency. One is primary valency, one is secondary valency. Primary valency giving you an idea about the oxidation state of the metal atom, and secondary valency giving you the coordination number of the complex, right? And so that is not your answer. It's not explained about the nature of bonding. While you're coming to valence bond theory, through valence bond theory, VBT, we studied how to determine the geometry, whether it is square planar, tetrahedral, octahedral, whether it is inner orbital complex, outer orbital complex, many things we can explain, right? But not the nature of bonding. While you're coming to crystal field theory explains the splitting of the d orbital of the metal atom in the presence of a ligand, strong field ligand, weak field ligand, like that. But crystal field theory also not explaining the length of the bond energy, and the bond nature of bonding, everything. It is not explained by crystal field theory. So the answer goes to molecular orbital theory. We can discuss detail about that. How? You know, this nickel is the metal atom. It is connected with a CO as a ligand, carbonyl ligand. Metal, when connected with a carbonyl as a ligand, they are a separate branch. You studied metal carbonyls, right? Metal carbonyls. There is a speciality in bonding in metal carbonyl, right? Here, nickel is connected with a CO as carbonyl ligand through a double bond nature. There is a double bond character. You know, in a double bond, one of the bond is sigma, one of the bond is pi. And the extra bond, normally they will form a sigma bond, but there is an extra pi bond is generated. That is known as synergic bond, right? We have studied that. That is called synergic bond. What is meant by synergic bond? It is called self-strengthening bond. Synergic bond means self-strengthening bond. You know, single bond, if you consider single bond and double bond will be greater, right? Yes. So here nickel, metal atom connected through the ligand through a double bond nature. And how this double bond is forming? Student, the sigma bond is formed by the overlap between, very careful, the sigma bond is formed by the overlap between the empty orbital of the metal atom with filled, or we can say the lone pair of electrons in CO. Once again, the sigma bond is formed by the overlap between empty orbital of the metal atom with the lone pair of electrons in CO ligand, sigma bond. And how the pi bond is forming? Pi bond is formed by the overlap between empty orbital of the ligand with filled orbital of the metal. And they are saying, they are specifying that, according to molecular theory, they are specifying that carbonyl ligand which contain empty p orbital. That empty anti-bonding pi star, which orbital? Anti-bonding pi star orbital, empty orbital overlapping with the filled orbital of metal and forming the synergic bond. Let's see. In carbonyl ligand, you know, CO, how many electrons are present in CO? You know, 1 carbon, 6 electron, 1 oxygen, 8 electron, 8 plus 6 equal to 14 electron, right? We studied in molecular orbital theory, a system contain up to 14 and more than 14. Up to 14 electron, we have a rule, or we have a energy, molecular orbital energy. What is the order? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and we have pi 2px is equal to pi 2py, and then we have sigma 2pz, and then we have pi star 2px is equal to pi star 2py, and last we have sigma star 2pz, right? And here let's fill the electron, total 14 electron. 2 electron here, you know, each molecular orbital can maximum occupy 2 electron. So 2, 4, 6, 8, 1 equally, then completely, right? 1, 2, 4, 6, 8, 10, 12, 14 electron that we filled. And it is very clear that the pi star orbital, the pi star p orbitals are vacant in CO ligand. These pi star orbital of CO will make a overlap with filled orbital of nickel, means the metal atom, and creating the synergic bond. So this synergic bond, or the bonding, nature of bonding in metal carbonyl is explained by MOT, molecular orbital theory. So your answer is option C. Okay, let's go to question number 30. The IUPAC name of the complex. Again the question from coordination complex. Very simple. The complex is given that, what is the complex? PT. Platinum is your central atom, central metal atom, and it is connected with the NH3 twice, 1 chlorine, and we have NH2CH3, and the counter ion is chlorine. Okay student, here platinum, that is your central atom. NH3, what is NH3 ligand? That is known as amine, right? Amine ligand, there are diamine. What is Cl? You know, a neutral ligand, just the name is enough, amine. But chlorine with a -1 charge, its name should end with O. Either you can write chloro or chlorido. So we can write chloro. And NH2CH3, what is NH2CH3? Methylamine, right? Methylamine, that's the one. And counter ion is chlorine. Okay, let's find the oxidation state of the central metal atom also. What is the central metal atom? Platinum. Suppose we don't know, X plus. Amine, you know, it's a neutral ligand, 0 plus. Chlorine, -1 plus. NH2CH3, methylamine is also a neutral ligand, 0 plus. You know, counter ion is there, right? Cl is there, its charge is also -1. Overall, 0. So you will get x minus 2 is equal to 0, x is equal to plus 2. So this is the oxidation state of platinum. You know, oxidation state is needed while writing the IUPAC name, right? Now we have different kind of, see here all of you, this coordination sphere is the initial part, cationic part, counter ion is the anionic part. While naming a coordination sphere, you know very well, first write the ligands in alphabetical order. Amine, C, M, A, C, M, right? It's correct order, right? Alphabetical. So here we can write that diamine, two amines are there, diamine, then we have only one chlorine. So chloro, methylamine, right? Methylamine, and the central metal atom is platinum. The platinum is located on the cationic part, so no need to write platinate, right? When we will use platinate, when the coordination sphere in the negative part, means anionic part. Here it is in the cationic part, so platinum is enough. So amine, then we have platinum. After the metal atom, we should write the oxidation state of the metal atom in Roman numeral. So it comes to 2. And what is the counter ion? Only one chlorine, that is chloride, right? Chloride. So which is your answer? Diamine. Diamine starting only two answer, option A and C. Diamine, chloro. Okay, fine. Diamine, chloro. Methylamine. Methylamine, platinum. Don't use platinate. Platinate is when we will use, student, when the coordination sphere located in the anionic part. So this is not your answer. Option A will be the correct answer for question number 13. Okay, let's go to question number 14. 1-methyl ethylene oxide, when treated with an excess of HBr, produces excess of HBr. So first of all, you have to know what is the compound 1-methyl ethylene oxide. Very simple. You know, ethylene oxide, one oxygen, and this is the ethylene one. Okay, this is the ethylene oxide, or for understanding, we can write like this one, CH2, CH2. You know, this is called what? Ethylene compound, right? Ethylene, one oxygen. It's nothing but it's a cyclic ether. Cyclic ether. And in which 1-methyl ethylene oxide. So there is a methyl group, student. There is a methyl group connected with this. Okay, fine. Methyl group is there. Good. Now, it is treated with what? HBr. Okay. It is first treating with what? HBr. Let us keep it like this. HBr is the compound. You know, oxygen. This oxygen having two lone pair. One of the lone pair, by using one of the lone pair, it can abstract the hydrogen. So what will happen? This bond shifted to Br. Br become Br minus. So we can write the compound here. The compound will be CH3, CH, CH2, and is converted to O. Already one lone pair is there, and this one lone pair donated, so it will get a positive charge and it accepted one H. And it is going to react with what? Br minus. You can see here Br minus is producing, right? So that Br minus will react, and where it will attack? It's a nucleophile. Where this nucleophile can attack? You know, student, nucleophile will prefer the less steric hindered part, means less crowded area. Either this bromine can attack to this carbon, or it can attack to this carbon. Where it is easy? Definitely this side, because there is a bulky methyl group. So when it attacked here, this bond shifted, and the next positive charge on oxygen will be cancelled. So you will get the compound CH, CH3, and here CH2. Now it is connected with a Br. This bond broken, and here OH. Right? OH. This is the compound you are getting. Okay. But it's not your final answer. Read the question carefully. We are treating with an excess of HBr. Right? Excess of HBr. Already we treated with one HBr. Suppose if you are treating with one more HBr compound, what can happen? You know, student, here we have a alcoholic group. So this OH and H eliminated as water. One more bromine can attack here. Right? Instead of this OH, one more bromine can attack here. What is your compound? it becomes CH3, CH, and it's connected with one Br and one more CH2 Br. So which is your answer? The final answer is option C, right? Question number 15. Consider the following reaction. The first species is what, student? N-N-dimethyl aniline, right? So let me take the compound N-N-dimethyl aniline here. NCH3, CH3. Okay? And it is going to react with which compound? That's given Na plus SO3 minus on the para position, with a diazonium salt. You know, diazonium salt is plus and we have Cl minus, right? These are the species. Let's write the mechanism here. You know, this nitrogen which contain a lone pair, what is this reaction actually? It's a substituted aniline. It's reacting with a diazonium compound. It is called coupling reaction. And here, the lone pair, it is an ortho-para directing group. So the lone pair can shift here. This lone pair can move here. And this double bond can attack on this nitrogen. Means they will create a bond. And this bond shifted here, the positive charge will be cancelled. And you will get the compound here, Na plus SO3 minus and the benzene ring with nitrogen, double bond with the nitrogen, and here it is connected, one pi bond comes here, already this pi bond here, and we have double bond N plus CH3, this is the compound we have, right? And after that, what can happen? In order to cancel this positive charge on nitrogen, you know nitrogen is an electronegative element, what can happen? One of the hydrogen can shift here, right? And then this pi bond moves and the positive charge on nitrogen will cancel. So you will get Na plus SO3 minus and the benzene ring and nitrogen double bond nitrogen and the again benzene ring aromaticity is retained and nitrogen CH3. This is the compound you are getting. And student, during this coupling reaction between N-N-dimethyl aniline and a diazonium chloride and sulfanilic acid group, it will undergo coupling and this resultant compound is known as methyl orange. This compound is known as methyl orange. You know, methyl orange is used as a acid-base indicator, right? Acid-base indicator. In base, methyl orange having a yellow color and in acidic medium, it having a red color. So the question, the forming compound X, this is your compound X and it is used as, you know that? It is used as an acid-base titration as an indicator. We have question number 16. Match the following. The riboflavin, thiamine, pyridoxine, ascorbic acid. So many vitamins are given. So the chapter biomolecules, vitamin part. You know riboflavin. What is riboflavin? That is vitamin B2. Thiamine, that you know vitamin B1. And pyridoxine is vitamin B6. What about ascorbic acid? It's vitamin C. You know there, what is on right side given? Their deficiency causes. Riboflavin deficiency, you know it causes chelosis or thiamine B1 deficiency causes what? Beriberi. And pyridoxine B6, its deficiency causes convulsions. And ascorbic acid deficiency causes scurvy. So first one with the R. Second one with the P, RP, right? RPSQ, right? Third one and fourth one. Yes, your answer is option B for question number 16. And we have question number 17. Given that the standard potential E0 value of Cu2 plus Cu is given and E0 value of Cu plus changes to Cu, that's also given. What's the value? 0.34 volt and here 0.522 volt. Okay, fine. Respectively, and we have to calculate the standard potential for the change of Cu2 plus to Cu plus. Okay, fine. Student, here the first compound, or let me write the first reaction here. What is the reaction? Cu2 plus converted to Cu. How Cu2 plus can converted to Cu? By gaining 2 electron, right? Let me take second equation. How Cu plus can converted to Cu? By gaining 1 electron, right? Yes, Cu converted by accepting 1 electron. And what about Cu2 plus? What about third one? Cu2 plus converting into Cu plus. How? By gaining 1 electron. Okay, this equation we need to find out. Let me take this equation number 1. This is equation number 2. You know, student, here E0 values are given, right? E0 values are given for Cu2 plus to Cu and Cu plus to Cu. We have to find out the E0 value for the conversion of Cu2 plus to Cu plus. Here both are reduction because they are gaining electron. Let me take number 1 and number 2 for these two. Okay, these two. Number 1, number 2. And here except gaining electron, here also gaining electron. So both are reductions. So we can't add their E0 value directly or subtract. We have to take their free energy method, Gibbs free energy method. You know, what is the relation between delta G or Gibbs energy with the E0 value? You know, delta G equal to minus NF E cell, right? Or standard Gibbs energy is equal to minus NF E naught cell. Here we are going to calculate delta G for 1 and 2. So delta G for first equation, what will come, student? Minus, what is N? Number of electron transferring, right? How many electron? 2 electron. So 2 into farad into, what is E0 cell for the first system? That's 0.34 volt. Okay, fine. Let me take this is delta G1. Let me take delta G2 for the second equation. How many electrons are transferring? 1 electron. So minus 1 into F into, what is the E0 value for the second one? 0.522 volt. Okay, fine. And we have to calculate the delta G3, means for this equation, this one we have to find out. So delta G3 is equal to, what we can write? Minus, how many electron transferring? 1 into farad into that E0 cell value we need to find out, right? Okay. So how can we find this value? Here, this is the relation between standard Gibbs free energy with the E naught cell value, right? We got delta G1, delta G2, delta G3. We have to generate this delta G3 by the combination of these two. How can we create? How can we create this equation or this equation by the combination of these two? See, Cu2 plus. In first equation, Cu2 plus is there. Cu plus. Here we need Cu plus on right side, but here it is on left side. We can inverse the second equation. So let's inverse the second equation. What it becomes? Inversing means it becomes Cu changes to Cu plus 1 electron, right? If you inversing the equation, delta G value also inverse. For the second equation, delta G is negative value, while you inversing it become positive value. So 1 into F into 0.522 is the value of delta G2, new delta G2 value, because you inverse, opposite sign also will be provided. And in order to get delta G3, means this third equation, let me add first and the reversed equation. Let me consider this is the fourth equation. So first and fourth equation let me add in order to get the third equation. So 1 plus 4, let me write. Here we will get Cu2 plus, right? These equations are your adding. First equation and fourth equation that we are adding. What is the first equation? E0 value, delta G1. That is, let me write delta G1 plus. Here you are adding delta G2, but it should be positive, right? Delta G2. Delta G2, that will be equal to the delta G3 for this equation. So it's equal to, What is delta G1 given? -2. You know, the farad will cancel each other, so no need to consider. So into 0.34 plus, what is delta G2 here? F into I told you F can be cancelled. Then we will get 0.522. So we can write that. What is this value? -0.68, right? Minus 0.68 plus 0.522. So it's approximately equal to minus 0.158. Minus 0.158. But your answer is not minus 0.158. It will be plus. Why, student? Because left side what you have? Delta G3, right? What is delta G3? That is minus 1 E0 cell. F will be cancelled. Minus sign is there. So minus E0 cell is there. So here E0 cell becomes a positive value 0.158 volt. Therefore your answer is option A. Let's go to question number 18. Here, a solution of metachloroaniline, metachlorophenol and metachlorobenzoic acid in ethyl acetate was extracted initially with a saturated solution of sodium bicarbonate. Okay, let's read one by one. You have the species metachloroaniline. You know, this is aniline and this is the metachloroaniline, right? What is the second one? Metachlorophenol. You have metachlorophenol. And what is the third compound? Metachlorobenzoic acid. Metachlorobenzoic acid. Okay, fine. And what you are doing here? This is treating with a saturated solution of sodium bicarbonate. Okay, let's treat with a sodium bicarbonate solution. So all these three compounds, let me treat it with what? Sodium bicarbonate, NaHCO3. Let me number, student. This is compound A, this is the compound B, and this is the compound C. Okay, fine. When we treat it with a sodium bicarbonate, you know, sodium bicarbonate, it will react with the carboxylic acid, right? And it will give you salt, water, and carbon dioxide. Which is the carboxylic acid part here? Only this, the C. So it will give you, this one will react, means C can react, and what you will get? When C react, it will get COONA, the salt, water and carbon dioxide, that you will get it. And they said to give a fraction A. Yes, that is your fraction. This is the one fraction A. Okay, fine. This is the fraction A. And the leftover organic phase, which are left over in this compound, A and B, right? Let me take A and B once more. You will get, NH2, and here you have chlorine along with the metachlorophenol that you have. Okay, fine. And the leftover organic phase was extracted with a dilute NaOH. It's going to treat it with the what, student? Dilute NaOH. Okay, dilute NaOH. It's a base, right? Where dilute NaOH can react? Which compound? Whether your compound A or whether your compound B, which will react? No doubt here, B will react, right? Because phenol is acidic in nature. So phenol will react with the base, it will form salt and water. So here you will get, what is the salt forming? Phenoxide, ONA, and water, and but the compound A won't react. The compound A won't react. Okay, this is your compound A, and this is your compound B is reacting here. And here, which compound is reacting? The compound C. Okay, fine. The question, the final organic layer was labeled as fraction C. Okay, so what about this? Yes, if you treat it with a dilute NaOH solution to give a fraction B. So which is the fraction B? This one, because it is reacting with the NaOH. And what about the final organic layer was labeled as fraction C, which is not reacting with both of them, this one. So that is your fraction C. Okay, fine. The fraction A, B and C contain respectively. Very simple. What is that? You know your fraction A, right? Your fraction A, which is that fraction A? This compound C, metachlorobenzoic acid. Metachlorobenzoic acid. So your answer either A or D. Fraction A is metachlorobenzoic acid. What about fraction B? Fraction B is metachloro, which one? Phenol. B is reacting, right? So metachlorophenol. Yes, your answer is option A. So a direct conversion, which of them are reacting, which will not react, that is a pattern of this question. So your question number 18, option A is the answer. Now let's go to question number 19. A very simple question. The electron gain enthalpy in kilojoule per mole of fluorine, chlorine, bromine and iodine respectively are, you know, the halogens. The halogens, you have fluorine, chlorine, bromine and iodine down the group, right? While you coming down the group, what happens to electronegativity? You know that? In general, tendency of electron gain enthalpy or electron affinity down a group is, what happens? It becomes less negative. So what we will think? Fluorine to iodine, it will be less negative, right? Less negative like that. But here, you have studied some exceptional characteristics in 17th and 16th group. While you coming from fluorine to chlorine, the exact order of their electron gain enthalpy is chlorine greater than, fluorine greater than, bromine greater than iodine. This is the exact order of their electron gain enthalpy. Why? Normally, down the group, electron gain enthalpy will be less negative. It should be decreasing. But fluorine and chlorine, why they interchanged? You know, fluorine is a very smaller element and chlorine is little bit bigger. While you consider about fluorine, how many electrons in their valence shell? 1, 2, 3, 4, 5, 6, 7. Chlorine also 1, 2, 3, 4, 5, 6, 7. Their outermost shell contain 7 electrons. What is meant by electron gain enthalpy? The amount of energy released when an extra electron added to the outermost shell of a isolated gaseous atom. Means one electron when you add it to the outermost shell, the amount of energy released. That is called electron gain enthalpy. Student, fluorine, you know, highly electronegative in nature. It have a tendency to accept electron. But when you add one extra electron to the outermost shell, it will repel. Why? Because already the size is very small. 7 electrons are in their valence shell. So already there are very high electron repulsion in fluorine, right? So into that system again you are going to add one more electron. So it will repel very strongly. So electron gain enthalpy will be lesser. But in chlorine, you can add electron fast because it having electronegativity. At the same time, enough space is there, less electron repulsion is there. It is ready to accept electron faster. So it having more negative value of what? Electron gain enthalpy. The same order, same tendency you may studied in oxygen family also. You know, oxygen family elements are oxygen, sulfur, selenium, tellurium, right? So oxygen and polonium also. Oxygen, sulfur while you coming, sulfur above should have and then oxygen will come. Okay, that's because of this reason. In fluorine which contain more electron repulsion. So fluorine having less electron gain enthalpy than chlorine. So in which case, here they given, this is correspond to, the first one correspond to fluorine, this is for chlorine, this is for bromine and this is for iodine. And in which case chlorine possess greater negative electron gain enthalpy. Where you can see that. Here chlorine greater electronegative value is possessed by option C. C minus 348 greater negative value, then fluorine, then bromine, then iodine. That is the correct order of electron gain enthalpy in halogen family. Okay, let's go to question number 20. Consider the following reaction. Option A. What is the reaction? CH3 thrice. Let me just expand, students. CH3 thrice. CH3 thrice. CHOH. Single bond CH3. It is treating with concentrated sulfuric acid. You know, a alcohol treated with a concentrated sulfuric acid means what? The reaction is dehydration, elimination of water. What is the question? Which of these reactions will not produce Zaitsev product? What is called Zaitsev rule? During the formation of an alkene, suppose if they are one or more product, if suppose you are getting two product, according to Zaitsev rule, more substituted alkenes are more stable. What's the point? According to Zaitsev rule, more substituted alkenes are more stable. Let's see what alkene is forming here. Okay. What is happened during when you treat it with a concentrated sulfuric acid? First, it will remove this OH and it will form a carbocation, right? What is the carbocation forming? Here you will get CH3, C, CH3, CH3 and CH plus CH3. This is the carbocation forming. Can you tell me what carbocation is this? Whether it is primary, secondary or tertiary? It's a secondary carbocation, right? It's connected to two nearby carbon atom. And in such cases, you just check it that whether this secondary carbocation can convert it into tertiary or not. Yes, there is a chance. How? This methyl group can be shifted to this carbon. That is called it as what? 1,2 methyl shift. It is called 1,2 methyl shift, right? 1,2 methyl shift. To the adjacent carbon, methyl group is shifting. If this methyl group shift, the positive charge will be here. So you will get CH3, C plus, CH3 and here CH, on which one new CH3, one more CH3. Correct? This is the one. And what will happen finally? Finally, we have to get what? An alkene, right? So the nearby OH already removed, one hydrogen has to remove. So this hydrogen shift here. So you will get the final compound CH3, C, CH3, C, CH3, CH3, double bond. Right. So when this compound undergo dehydration, there is a chance to get two alkenes. Either the double bond can be this side or it can be in this side. Which will be the more substituted alkene? The double bond comes in this side, means this, right? So there are two alkene can be formed, but according to Zaitsev rule, this is the more substituted alkene is the more stable product or major product. So it obeys Zaitsev rule. The question, which of these reaction will not produce Zaitsev rule? Okay, let's go to the option B. In option B, the compound is given CH3, CH3 and here we have CHBr and CH3. What is treating? It is treated with alcoholic KOH. You know student, alcoholic KOH reaction means what? Beta elimination or dehydrohalogenation, right? How is happening here? The K plus will remove halogen from alpha carbon. You know, functional group directly connected carbon is called alpha. Nearby carbon is called a beta. So how many carbon atoms are there? Beta. 2 beta carbon atoms are there. So K plus will remove bromine from alpha carbon and KBr is eliminating. OH minus will take one of the hydrogen from beta. Either you can take from this one, either you can take from this one. Suppose I am removing from this first. You will get a alkene here, right? Because these two species are eliminating, right? So you will get CH3, CCH3, double bond CH, single bond CH3. This is one of them. If you are removing this beta hydrogen, there will be a double bond here. And you will get CH3, CH, CH3, single bond, CH, double bond, CH2. These are the two alkenes. So here two alkenes are forming, but according to Zaitsev rule, which is more stable product? This one, because this is the more substituted alkene, right? So here also Zaitsev rule is obeyed. So let's go with the option C. What is option C? This given CH3, I think the same species like here, CH3, CH3 and CHBr along with one CH3, okay? It's treating with CH3 thrice CO minus K plus. What is this compound? This is tertibutyl, right? tertbutyl with oxygen. It is called potassium tertbutoxide. The potassium tertbutoxide. It is the basic part here. See the problem. It is just like mechanism is same like when you treated with alcoholic KOH. Process is dehydrohalogenation. But what is the problem here? If you remove the Br from this compound, what you will get? CH3, CH, CH3, and here you will get CH plus and CH. This is the carbocation forming, right? Okay, in this case, student, this nucleophile or this base part, this basic part, it cannot, it's a bulky group, student. See what is the basic group here? CH3, CCH3, CH3, O minus. This is the one you have, tertbutoxide. It is a bulky group. See, methyl is a bulky group, right? Overall, it is a very big bulky group. So, it cannot attack here to remove which one? This hydrogen atom. Because HBr has to remove, right? In order to remove the hydrogen, this nucleophile or this basic part, the tertbutoxide part, cannot attack here directly because already there are 2 CH3 in this base also. It's a bulky group. So, the reason here, the base which is using should be smaller in size, then only it can attack easily. So in this compound, it is not possible to make a product which is following Zaitsev rule. So this hydrogen you cannot remove here, okay student, this hydrogen you cannot remove. Instead of that, where it can attack, this position it can attack because it is less steric hindered position. This hydrogen can leave, the double bond will be here. So what you will get? CH3, CH, CH3, CH, double bond, CH2. Is it a product which obeying Zaitsev rule? No. According to Zaitsev rule, more substituted alkene has to generate. More substituted alkene mean the double bond should be here. Right? So this is the product forming, it is not obeying Zaitsev rule. So your answer is option C. Let me check it with option D also. What is option D compound given? It's given that CH3 twice, C in which one OH group, and then we have CH2CHO. It's on heating. What is this compound first? You know, here the main functional group is aldehyde and this is called the alpha carbon, it's called beta. Beta contain one hydroxy group, right? It's known as beta hydroxy aldehyde, right? Beta hydroxy aldehyde, or it is known as aldol, right? Because it contains both aldehyde and alcohol group. And when an aldol on heating, definitely it will undergo dehydration and it will form an alkene. Let's see what alkene is forming here. See, the OH is eliminated from beta carbon. You can eliminate hydrogen from any of the nearest carbon, either this or this. You know, so the most or the major product we can assign, I'm taking hydrogen from this one. Why? Because according to Zaitsev rule, when the double bond formed here, it will be the more substituted alkene. So let me write the product here. CH3, CCH3, double bond, CH, single bond, CHO. This will be the product. When an aldol on heating, you will get enal because it contains alkene and aldehyde, enal. This is also a Zaitsev product. So, which of this reaction will not produce Zaitsev product that we studied? Option C, because this nucleophile, that attack is very difficult because tertbutoxide is a bulky base. Okay, we can go to question number 21. Question number 21 is two solutions are there, A and B. Each of 100 liter was made by dissolving 4 gram NaOH and 9.8 gram H2SO4 in water respectively. Okay, fine. Let's take two solutions. One we have solution A and we have solution B. What solution A and B? Each of them are 100 liter. So let me take 100 liter of A and 100 liter of B. And first solution contain around 4 gram NaOH and the second species contain around 9.8 gram of sulfuric acid H2SO4 in water. Okay, fine. The pH of the resultant solution obtained by From that, student, from this one we are taking 40 liter of A and 10 liter of B. And what will be the pH of that solution? That is the question. See, this is the initial one. Let us find out what is the number of moles of each component. What is the number of moles of NaOH? You know, number of moles is calculated by given mass by molar mass. What is the given mass? 4 gram. What is the molar mass of NaOH? 40. So 4 by 40, that's equal to what? 0.1 mole will be there. What about the number of moles of sulfuric acid? Given mass is 9.8 gram and molar mass is 98. Why we are calculating number of moles? Because in order to calculate pH or pOH, we need the concentration, right? Yes. So 9.8 by 98 will be 0.1 mole. Okay, fine. So we have in this initially 0.1 mole of NaOH, 0.1 mole of H2SO4 in 100 liter separate solution. Okay. From this one, we are taking 40 liter of A and 10 liter of B. Okay, let us take here, student. From this one, let me take 40 liter of NaOH. Okay, 40 liter of NaOH and how much from B? 10 liter. 10 liter of solution B means sulfuric acid solution. Fine. 40 liter NaOH. All of you listen. 100 liter NaOH solution, the number of moles is 0.1, right? So what is that? The point here it is 100 liter of NaOH. The number of moles we got it 0.1 mole. Similarly, what will be the number of moles in 40 liter? So 40 liter NaOH contain 0.1 by 100 into 40, right? 40 liter. That will be the number of moles in 40 liter NaOH. So how much? It will be 0.4 by 10, it will be equal to 0.04 mole will be there. What about sulfuric acid? See, 10 liter H2SO4 that we are taking from this one. Initially what we have 100 liter H2SO4. See, 100 liter H2SO4 that's equal to how many moles? 0.1 mole present. If it is 100 liter H2SO4 contain 0.1 mole H2SO4, how much contain in 10 liter? So 10 liter which contain 0.1 by 100 into 10. That's equal to what? 0.01 mole, right? This is the mole. But here the main turning point of this question is, here you are reacting NaOH with sulfuric acid, right? NaOH that we are going to react with sulfuric acid. See student, NaOH, the number of OH minus is just 1, but in H2SO4 the H plus ion is 2, right? 2 H plus ion is reacting with 1 OH minus ion. Here we have the NaOH number of moles is 0.04. Here the number of moles of H2SO4 is 0.01, but H2SO4 contain 2 H plus ion. 2 H plus ion. So what will be the number of moles of H plus? It will be 0.02. Once more. NaOH in 40 liter NaOH the number of moles is 0.04 mole and the number of moles in 10 liter H2SO4 is 0.01. But NaOH contain only 1 OH minus, so the number of moles of OH minus will be the same. But H2SO4 contain 2 H plus ion. Why we are considering H and OH? Because we are going to find out pH, right? So in sulfuric acid there are 2 moles of H plus. So that you should multiply. This is the number of moles of H plus in the overall system, 10 liter H2SO4. So what are the species overall? It is reacting here 0.04. 0.04 mole of NaOH is going to react with 0.02 mole of what sulfuric acid is reacting. Okay, fine. If these two species are reacting each other, see which is the limiting reagent here? 0.02, right? Smaller in amount. So 0.02 mole of H2SO4 will react with 0.02 mole of NaOH. Okay, it will neutralize. So how much NaOH left in the system? Yes, 0.02 mole H2SO4, sorry, NaOH will left in the system. We got number of moles of NaOH, right? So let's calculate its concentration. What is the concentration? Suppose molarity. Molarity is what? Number of moles by volume, right? Number of moles of NaOH is 0.02. What is the volume? See, 0.04 you are getting from 40 liter NaOH. 0.02 you are getting from 10 liter. So 40 plus 10, what is the overall mixture? See, 10 liter NaOH that you are mixing with the 10 liter solution B that you are reacting with the 40 liter A. So total what is the volume? 50, right? 50. So 0.02 by 50, that's equal to what we can write? 2 into 10 to the power minus 2 divided by 5 into 10, right? It will come 10 to the power minus 1. 2 by 5, 0.4. 0.4 into 10 to the power minus 3. We can write that 4 into 10 to the power minus 4. Yes or no? This is the concentration of what? It is the concentration of NaOH, right? You know, NaOH, if there are 4 into 10 to the power minus 4 molar NaOH, we can say that there will be 4 into 10 to the power minus 4 molar OH minus. So this is the concentration of your OH minus, right? So OH minus ion concentration, we getting 4 into 10 to the power minus 4 molar. If you know OH minus concentration, we can find the POH, but question pH. First we can calculate POH. What is POH, student? Negative log of OH minus. So we can write here negative log of 4 into 10 to the power minus 4. See, this is log A into B format. So minus of log A, log 4, right? Log 4 plus log A into B is log A plus log B. So log 4 plus log 10 to the power minus 4. Log 10 to the power any value, the value itself. So it will be minus 4. So it's equal to, what is log 4? You know, log 4 is equal to 0.6 plus minus 4 will be there. Okay, minus 4 is there. So while you coming to multiply the negative sign inside, you will get 4 minus 0.6 is equal to around 3.4. But we need pH value. You know, student, pH plus POH, that's equal to total is 14. So pH will be 14 minus POH, means 14 minus 3.4, it's around 10.6. That will be the pH value of 40 liter A solution when you mix with 10 liter of solution B. Okay, so the answer question number 21 is pH value 10.6. Okay, fine. Let's go to question number 22. Here we have, during the nuclear explosion, one of the products of strontium-90 was absorbed in the bones of a newly born baby in place of calcium. Fine. How much time in years? So the question is from the chemical kinetics chapter, right? So how much time in years is required to reduce it by 90%? So T 90% that we need to find out. And if it is not lost metabolically, and half-life, T half, what is T half? 50%, right? Half of their completion. T half is given that around 6.93 years. Okay, fine. So T90 we need to calculate, T50 already given. Let's compare them. Let's take their ratio. Here, T90, let me take the ratio. T90% divided by T50% is equal to. How to find out time for a first order reaction? You know, for a first order reaction, time is equal to 2.303 divided by K into log of initial concentration divided by the finite concentration. See, while you're taking T by T, 2.303 by K, it will be cancelled, right? So here we can write 2.303 divided by K into log of 90%. So initially how much? 100. 90% that is reduced, right? Required to reduce 90%. After reducing, how much will be left in the system? 10 only. Divided by, what is T50? 2.303 divided by K into log of initially 100, after 50%, what is left? 50, right? So you can cancel here. So it will be T90% divided by T50% is equal to log 100 by 10. Log 10, log 10 is equal to 1. And here log 100 by 50, that's equal to 2. Log 2, what is the value? 0.3010. Okay, and log T90% we need to find out. So 1 divided by 0.3010 into, what is T50? T50, that's already given here, 6.93. So almost you will get the answer 23.03. 23.03 years. That's the time taken for that 90% their completion. So question number 22, the answer is 23.03 years. So we can compare their values. Let's go with question number 23. Chlorine reacts with hot and concentrated NaOH, right? Here the question is from your chapter P block, 17th group, right? Grade 12 P block. Chlorine reacts with the hot and concentrated NaOH. We studied what will be the reaction when NaOH reacted with the Cl2. Two reactions we studied. So let me write the two reaction here. NaOH plus Cl2. In first case, we are considering cold and dilute NaOH, right? First we are considering cold and dilute NaOH. And second case, we are taking hot and concentrated NaOH. That is our question. When you treated NaOH with a Cl2, cold dilute, you will get the compound NaCl, right? NaCl with water along with NaOCl. What is NaOCl? Sodium hypochlorite. When you treat hot and concentrated NaOH with chlorine, it will give you same thing, sodium chloride, water, but instead of NaOCl, it will give you NaClO3, sodium chlorate. What's the compound? Sodium chlorate. Okay, fine. So we need this equation in this question. So chlorine reacts with the hot and concentrated NaOH and produces compound X and Y. So we need to find out which is X, which is Y. Simple. Compound X gives white precipitate with silver nitrate. So student, what are we going to consider? NaCl or NaClO3, which will give a white precipitate when you treat it with a silver nitrate. Definitely which one? NaCl, right? If you treat NaCl with the AgNO3, it will give you the white precipitate AgCl. AgCl, silver chloride is in white precipitate. So you can confirm that your compound X is NaCl, this one, and the compound Y is this one. Okay, fine. And the average bond order, bond order means what? Number of bonds between two atoms, right? The average bond order between chlorine and oxygen atom in Y. What is Y compound? Your Y compound is nothing but sodium chloride, NaClO3. What is the nature of bonding in NaClO3? Na plus. What is the anionic part? Cl. Chlorine, it's having total 7 electron in their valence shell, right? Total they're having 7 electron in their valence shell. It is surrounded by 3 oxygen atom. So here 2 of the oxygen are making double bond, 2 of them making double bond, 1 of them making single bond. It's having negative charge and 1 lone pair is left over. This is the structure of NaClO3. And the question, the average bond order between chlorine and oxygen. Student, we have the equation to calculate average bond order is. What's the equation? See this pi bond, this lone pair is present on this oxygen, it can involve in resonance, right? So total how many resonance structures you will get it for this compound? 3. right? This double bond can be on this oxygen or this oxygen or this oxygen, like that. 3 resonating structures that you will get it. How to find out average bond order in between this chlorine and oxygen? That is the question here. Very simple to calculate. Average bond order is calculated by the total number of bonds involved in resonance. Total number of bonds involved in resonance. Total there are 5 bonds between chlorine and each oxygen. So all these bonds can involved in resonance. So total number of bonds involved in resonance is 5. Or you can say the number of individual bond order. Individual bond order. How many bond order between this chlorine and oxygen? 1, 2. What is bond order? Number of bonds between 2 atoms. There are 2, right? So 2 plus here 2 plus here 1. Okay, divided by. I told you either you can take the number of bonds which involved in resonance. All these 5 bonds are involved in resonance. That is the numerator, divided by, and the denominator is total number of resonating structure. How many resonating structure you will get it here? We already discussed that. This double bond can be here, here or here. Total there are 3 resonating structure. So the answer will be 5 by 3. 5 by 3 is nearby. 1.666. It will comes almost, we can take 1.67. So the bond order in between, the average bond order in between chlorine and oxygen is 1.67 is the answer. So question number 23, the answer is 1.67. Okay, let's go to the second last question, question number 24. The number of chiral carbons in chloramphenicol is, chiral carbon means the carbon, its 4 valency must be satisfied with a 4 different group, right? Yes. Those students who know the exact structure of chloramphenicol, they only can proceed this question. Student, chloramphenicol is a medicinal purpose one. It is used as an antibiotic. What is the structure of chloramphenicol? It's having a benzene ring. Its para position is attached with a nitro group, and thus is connected with one OH, and here one another OH, and we have NH. It's having one lone pair, and then we have a CO group and CHCl2. This is the structure of chloramphenicol. So chloramphenicol, in this structure, total how many chiral carbon atoms are present? You don't need to bother about benzene carbon because they are achiral, right? And what about this carbon atom? It's connected with one OH, one phenyl ring, a bulky group here, and another separate group here, and one hydrogen. Yes, all the 4 valencies are satisfied by 4 different groups. So this one is a chiral carbon atom. Any other chiral carbon? This carbon is definitely, it is not a chiral, right? Because 2 valency are satisfied with the same element, it is achiral. What about this carbon? Its 2 valency satisfied with the same element chlorine, it is also achiral. And which is remaining carbon? This carbon, it having 2 hydrogen, right? That is also achiral. But what about this carbon? It's connected with the CH2OH, one group, and CHOH, one another group, NH, one another group, and contain one hydrogen. Yes, this is also a chiral carbon atom. So total there are 2 chiral carbon atom in the medicine chloramphenicol. Its answer is 2. Okay, let's go to question number 25. Let's go to the last question. Here we have, for the reaction, what's the reaction given? A is a liquid compound, that is your reactant, which on reaction is giving 2B and it is a gas. What are the compounds given here? The data are given. The change in internal energy, delta U is equal to 2.1 kilocalories, and entropy change, delta S is equal to 20 calories Kelvin inverse, and at a temperature is given 300 Kelvin. Okay, fine. What is the value of Gibbs free energy delta G? Very simple question. Student, if they given internal energy, if they given entropy delta G, we have the equation to calculate delta G, that is Gibbs-Helmholtz equation. What's the equation? Delta G is equal to delta H minus T delta S. But unfortunately, delta H is not given directly, but by using delta U, we can calculate delta H. So, delta G equal to, what you can write it for delta H, we have to calculate delta H by the equation delta U plus delta NGRT, right? This is the value of delta H minus T delta S. Here delta G is given in kilocalories. So, by the initial step itself, better to make in kilocalories every value, then it will be final, a correct answer, you will get it. See, delta U is already given 2.1 kilocalories, already kilocalories plus, what is delta Ng? You know, delta Ng is change in number of moles, right? Which number of moles? Number of moles of gaseous product minus number of moles of gaseous reactant. You don't need to bother about solid or liquid component, only gases. Number of gaseous product minus gaseous reactant. How many gaseous product you have, student? 2. How many gaseous reactant? Nothing, right? It's liquid. So 2 will be the Ng value. So 2 into, what is R? Universal gas constant. We need the value in calories, right? Kilocalories. So R value in calories actually 1.98. Actually it is in calories, Kelvin inverse, mole inverse. But we need kilocalories, right? Okay, let's substitute the value 1.98. How can you convert calorie into kilocalorie? By 1000. Okay, into, what is the temperature given? Temperature is given here around 300, right? 300. No problem here, almost you can take 1.98 as 2. Okay, no problem. 1.982 by rounding, you can write it as almost 2. Okay, this is the one. We have the value of delta, which one? H overall. Oh, minus. Again, temperature, that's around 300. Into, what is change in entropy? That's 20, student. 20 calories, but should be in kilocalories divided by 1000. Okay, let's evaluate. This one we can cancel. These two, these two, these two. What you will get? 2.1 plus 2 into 2, 4, 4 into 3, 12. 12 by 10 is equal to 1.2 minus 3 into 2. That's equal to 6. So the overall value 2.1 plus 1.2 is around 3.3 minus 6. That's equal to 2.7. Right? Minus 2.7. What is the value? Kilocalories. So the delta G value in kilocalories is minus 2.7. So this is the answer for last question number 25 from the chapter Thermodynamics, grade 11. So here we discussed the last year JEE main chemistry questions in detail. Hope you clear the entire questions and their detailed answer. So we will meet again with lot of interesting other questions from chemistry for your JEE main in the upcoming sessions. So thank you all. Bye all of you.